top of the morning or afternoon, whatever time you decide to check in. This is Coach Mike, and it's the first installment of Talk That Math Talk. By the end of this video, we should fully understand a few things. 1, how to categorize real numbers. 2, what a perfect square is and how we find the square root. 3, there are such things as non-perfect squares, and we still need to find the square root of those.
So we'll approximate.
4, figure out what all of this has to do with
the Pythagorean theorem.
And then you'll be able to complete the assignments. There'll be worksheets in between, allowing you to go ahead and show what you've learned. So get ready, get your mind, your materials, and your body ready to learn something. And let's leave smarter. First things first though. And follow up with this. All right, let's go. All right, so you've seen this happen before. Where we have real numbers and we have a Venn diagram talking about how everybody is related to each other. But let's go ahead and go over it again like it's brand new. Imagine that you have the universe of real numbers, okay? Now, the universe of real numbers, we're going to act like it's like ours, okay? Everything is all together. However, we have Earth, which is going to be our rational numbers. Imagine that to be Earth. In rational numbers, rational, the root word of rational is ratio. The word ratio means as a fraction. So if it can be written as a fraction, and my definitions are off to the side, but if it can be written as a fraction where the decimal stops or repeats, then that is considered to be a rational number. Integer we have here are my whole numbers and their opposites, positive numbers, negative numbers, and 0. Whole number, the word whole, reminds me of a whole, like 0. So 0 and all my positives is whole numbers, and then natural numbers is how we naturally count, starting at 1 and going up from there. Those are all my rational numbers, all right? And again, if it can be written as a ratio where the decimal stops, then it's anywhere in here. And everybody under there are also rational numbers. So we have integers, which are rational numbers, but we limit ourselves to only whole numbers, positive and negative, and 0. And then we have whole numbers, which are only from 0 and my positives. And then we narrow it down some more to natural numbers, but all of them are considered rational numbers. So imagine the Earth is rational numbers. North America would be integers, the United States would be whole numbers, and then the state of Texas would be natural numbers. You kind of understand now? Are all numbers rational? No, they're not. But here are some special numbers that we need to worry about. Perfect squares. It is the product of a number and itself. Itself is important. That means the same number. For example, 25 is a perfect square because 5 squared is 25. That means 5 times 5 is 25. So 25 is a perfect square. And then we have 49 because Shavon squared is 49. So that means 49 must also be a perfect square. If we're going backwards, though, we go from perfect squares to square roots. A square root is that factor of a perfect square. For example, the square root of 81 is 9 because 9 squared is 81. So that's where that comes from. All right. And the example at the bottom, you can also see the same thing. Okay. Now, all of these also fit under rational numbers. Even though we have the radical sign, they're still rational. If they're not perfect squares, they're called irrational numbers, like the square root of 10 and pi, which is a very popular irrational number. It's not really 3.14. That's an approximation. It's really 3.14 and a lot of other things. The universe of real numbers with rational and irrational.
Talk that math talk.
All right, let's step it up a notch and let's take it to the next level. We talked about real numbers, rational numbers, integers, whole numbers, natural numbers. Now we're going to start talking about perfect squares. My boy was thinking. He was like, why do we even call them perfect squares? Well, I'm glad you asked. I don't know if this is the real reason, but in my mind, I'm thinking, let's say we actually have a perfect square. What does that mean? That means we have a shape with 4 sides, and every single side is the exact same measurement. If we had 4 actual squares, we can make a perfect square with one side being 2 and the other side being 2. Oh, okay. So a 2 by 2 or 2 times 2 is 4. So 4 must be a perfect square. All right, keep going. Bet. So let's look at another number. If we had 25 little squares, would we be able to make a perfect square with the length and the width being the same measurement? Well, let's see. If we break it down with 5 columns, and then we have 1, 2, 3, 4. That makes 5 rows. It's 5 by 5. Dang, that is a perfect square. So 25 is a perfect square because 25 squares would make a perfect square. All right. What if we had 10? Oh, that's light. What's that? 5? Yeah, because 5. Wait, that's not right. If I had 10 squares, what would that look like? If I had 10 squares, I could make a row of 10 where it's 10 by 1, or I can make a 5 by 2, but dang, that's not gonna give me a perfect square. So 10, even though we want to quickly say 5 is the square root of 10, it's not. 10 is not a perfect square because if I had 10 squares, I couldn't actually create a perfect square. All right. So let's look at 16. If we had 16 squares, could we really make a perfect square? Let me see. Yep. Yes, 4. A 4 by 4 would make a perfect square of 16.
Talk that math talk.
Now, the last level of the universe of real numbers will come in these notes. We've already talked about the world of rational, where there's rational numbers, integers, whole numbers, and natural numbers. And we even talked about perfect squares. But let's talk about that other planet, irrational numbers. Now, when you have to find the square root of a number that is not a perfect square, you will get yourself an irrational number. My boy was thinking. He was like, does every number have a square root? And what if it's not even a perfect square? Then what do we do? Well, as always, I'm glad you asked. In the event that it is not a perfect square, we can still find an approximated square root. For example, let's say we are trying to find the square root of, let me think of a number. It's not a perfect square. Well, that symbol, by the way, is called a radical. How about 40? Now, the easy misconception would be, oh, that's 20, because half of 20 is half of 40 is 20, and that's true, but that's not what we're looking for. What we're trying to see is what number times itself will get us 40, and the truth is there is no number times itself to get 40, so we have to approximate. We're going to get ourselves a quick scale to put it on, and we're going to look on the left side of 40 and the right side of 40 and look for 2 perfect squares. Now 36 will be our closest perfect square that is less than 40. Remember, a perfect square is a number, the product of a number times itself, and 36 would be that, and the square root of 36 is 6. On the other side, we have 49. That is the closest perfect square greater than 40. Again, that's because a number times itself will get me 49, and that number is going to be 7. So we look at the square root of 36 is 6. The square root of 49 is 7. And there'll always be 2 consecutive numbers for the record. If one is 6, the other is 7. If one is 8, the other is 9. If one is 10, the other one's 12. If one is 15, the other one is 16, so on and so forth. It will always be 2 consecutive numbers. So we know that the square root of 40 will not give us an actual integer at all. So we need to look at a number line, and remember, there are lots of numbers in between 6 and 7. So if we look at a number line and just rounding to the 10th, we'll have 6.1, 0.2, 0.3, 0.4, 0.5, 6, 7, 8, and 9. And we know that the square root of 40 will fall somewhere in between the number 6 and the number 7. The question is, where? So we look at the distance that 40 is from 36. 36 to 40 is only going to give us, 4. And then the distance between 40 and 49 is 9. There we go. All right. So since 40 is closer to 36, the square root of 40 will be closer to 6. Now, since it's not like super close to 36, I would say it's something like right here-ish, maybe like 6.3, 6.4. And the way that we're going to be able to figure it out a little more accurate, let me see, I'm going to guess it's something like 6.4. That's my educated estimation. But the way that we can make this a little more accurate is we go ahead and take out our calculator, preferably the TI-84, because that is the one that is going to be used on the STAR exam. We pull that out, go ahead and clear really quick, show you the buttons to push. We push second and the X squared button, which activates the radical behind it. And then you press 40 and press enter. This is what it looks like on the big screen. Square root of 40. Press enter and it's not bad. We have 6.3. My estimation was 6.4. So we're pretty good there. And again, it's not going to be a whole number. It's not even going to be a terminating decimal, because there does not exist a number times itself to get us 40. All right, so that one is my example. Let's go ahead and look at another example really quick. Say we have the square root of, let me think of a number. Let's do square root of 116. All right, so we know that there does not exist a number to multiply times itself to get 116. So we put it on a scale, put it in between two perfect squares, 100 and 121. The square root of 100 is 10. Square root of 121 is 11. The distance between these two is 16. Between these is 5. And we try to see, is 116 closer to 100 or 121? 121. Now, since the square root of 116 is closer to 121, then the square root of 116 must be closer to 11. Still starting with 10 because it's in between the numbers 10 and 11. So 10.7 is my estimation. But of course, let's use a calculator. Pull out the calculator real quick. Second, X squared, and then press 116. On the big screen, it looks like this. Square root of 116. Enter, and we get 10.7. That's that.
Talk that math talk.